Hi, I'm Mike DeVore, and this is my sample lesson. I'm a retired teacher, been a retired high school math teacher, and I've been doing it for 20 years. So all this are my lessons will usually be done via PowerPoint, as a just as a canvas for my annotation, or OneNote. So all this stuff is original; it's all my own. And let's go ahead and get started. Actually, before we get started, all my lessons would always start with some sort of a warm-up. So, like for example, we're going to have a lesson on the introduction to trigonometry. I would start with a warm-up that has some similar triangles, and then similar triangles, and really start talking about this angle theta as a transition into the actual lesson. So let's just go ahead. We won't go over this problem here. We'll just kind of jump right into the lesson. So I am going to kind of rush through this just because I know that it's supposed to stay between 5 and 15. 5 is pretty impossible for me, but we'll make this pretty quick. Okay, so let's go. All right, so this will be our first introduction to trigonometry, and we're going to start off with what are called trigonometric ratios. And when we talk about trigonometry, well, it really is based on a right triangle. And we've had a lot of experience with right triangles. And typically, when you guys think right triangles, we think of the Pythagorean theorem. And so a squared plus b squared equals c squared. Well, those have particular meanings. And so we know that c squared is always the hypotenuse. And the hypotenuse is always the opposite side to the right angle. And it is also always the long side of a right triangle. Now, when we use the Pythagorean theorem, we call the other two sides the legs, and they're pretty interchangeable, at least for the Pythagorean theorem itself. You can really say it's leg squared plus leg squared equals the hypotenuse squared. So, but now when we start talking about trigonometry, or I'm going to go ahead and abbreviate that trig from now on, we really start focusing in on the angle and its relationship in these right triangles. And as we saw in the warm-up, if I have a set angle, all of a sudden that does something to our, that has a relationship with all right triangles that have an acute angle that is the same, okay? So in this case here with trig, it's not just leg. We actually, those legs have meaning now, and here's I guess what I mean. Okay, now we actually have an order across from the angle of interest. In this case, theta. This side now is not just a leg; it's the opposite side, and this right here next to that angle is the adjacent side. So now these legs aren't just generic legs; they have, they have a place. Okay, if I were to switch my angle of interest up here, all of a sudden this is not correct. Okay, because this is my angle of interest across over here. That's now going to be the opposite, and that's adjacent. So remember that as we kind of label the sides, it does depend on the angle that we're using. Okay, so just like we had in the warm-up too, if I have a right triangle, okay, and I know that the right triangle has any of its acute angles the same, if that's true, then I know by angle similarity that these two are similar triangles. And if they're similar triangles, all the sides are proportional, and that's the whole basis of trigonometry and the trigonometric ratios. Okay, so these will be proportional. Okay, so let's jump right into it. We'll start with our first ratio, and that's the tangent ratio. And we typically will abbreviate that tan, but we never say tan so much as we'll say tangent. And notice we'll say the tangent of an angle, this angle theta. So our ratio is this, okay? In this case here, we're saying the opposite over the adjacent, and that's the ratio. It's just a ratio. Okay, opposite over adjacent. And remember, that is going to be consistent no matter what how big or small the triangle is. If I have some angle here, like if this were, say, 30 degrees, okay, I know that the ratio of this side here to this side will always be constant. It'll be the same whether it's this side to this side, just because these similar triangles are proportional. Okay. So our next ratio is sine. And here now we're going to be using opposite in the hypotenuse. So in this case, again, it's a sine ratio, and we have the sine of theta is opposite over hypotenuse. Now, here's the way we abbreviate it. Please don't call this sin of that. That's sine. So we read that as sine, but spelled out as sine. Okay, and that's now the opposite over the hypotenuse. Again, remember, it's related to this angle here. Okay. Our last one, we use the hypotenuse and the adjacent, and that's called cosine. And that's the adjacent over the hypotenuse. Now, again, we don't call this cos. We call it cosine. We use the whole name. So when you see cos in your textbooks or anywhere in math, that's always we say cosine. Okay. Now, these comprise the trigonometric ratios that are the foundation of trigonometry. If you were to look at your calculator, you would see these right here in your calculator. In other words, right here. So you'll see these are the main functions: sine, cosine, and tangent. This stuff up here, we'll learn this later. These are called the inverse functions. But right now, we're just going to concentrate on sine, cosine, and tangent. You will see this a lot, and this is just a way to remember these ratios. And virtually everyone has learned this. It's easy to just like go on YouTube and you can see this everywhere. And it's called SOHCAHTOA, and it's very common. And what it is a way for, it's an acronym to help you with this. Okay, and SOHCAHTOA stands for this. So is our sine, ca is our cosine, and toa is our tangent. And what that is just this: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we can see that right here. So that is a really handy thing to, there's not a lot of things in math that you should really, really commit to memory, but this is one of those. Okay. So what do we use this stuff for? Well, we use it primarily, at least to start, we're going to use it to find, we're going to solve for sides. And what happens, we find the missing sides of a right triangle, given we have to have at least one side and we must have at least one of the acute angles. That means either this angle here or this angle up here. So let's go ahead and try a couple problems. Okay. So as always, make good diagrams, because this will help you. Okay. All right, so we're looking for this side right here. So right now, our triangle has 0 information. So remember, we need to have another side and we need to have an angle. So I'm going to go ahead and use this angle here, 32 degrees. Okay, so we have an angle. Now, again, to find this, we need one of these two sides. So right now, if you think about what we have to this angle, we have the adjacent side to that, right? Over here is the hypotenuse, and over this one over here is the opposite. So right now, though, we have adjacent. So if we're going to use a trig ratio, we have to have one that has the adjacent. So I look over here, so that I don't have that, right? I have opposite and hypotenuse, but I do have the adjacent in here. So maybe I'm going to use cosine, or maybe I'm going to use tangent, because I also have adjacent here. So I need one more little nugget of information. Okay, so now I've put up here 15, and that's the hypotenuse. So at this point, I have an adjacent and an hypotenuse. So what I'm going to use is I'm going to use the cosine. Okay. So we're using the cosine, and this is what I highly recommend you do every time. You write out the ratio that you're going to use. The next thing before you start solving, you're going to want to do what we call setup. Okay. Now I'm just going to replace everything that I have. My 32, I'm just going to replace it here. This 15, that's my hypotenuse. I'm going to put that in here. And this is my unknown that I'm going to end up solving for. Okay. So this is our setup. And you should always put this, before you do anything else, do the setup. Now, the last thing, remember, we want to find the value of x, so we're solving, and this is just an equation. So we want to get x alone, and of course, we multiply both sides by 15, and now we actually, that's the solution right now. Now, hard to conceptually right now understand this cosine of 32, this is just a number, just purely a number. So we're saying 15 times this number will give me x. So this would be our solution if we were just asked for it in terms of trig functions. And often in a sort of test where you're not allowed a calculator, this would be it and you'd be all done. Okay. If you did plug that into your calculator, we'd find it's 12.7. Okay. Now, something curious here that you may have already noticed. Well, remember, if I know that this is 32 degrees, these two have to add to 90, right? Triangle sum theorem. So that has to be 58, in which case, well, can't I just do this? Isn't that now the opposite over the hypotenuse? Well, actually it is. So should we get the same answer? Well, we should. Let's just check it out, okay? So now if I instead consider this angle, which I can get pretty easily, I'll go ahead and use this. Sine is opposite over hypotenuse, which is x over 15. And again, that's our setup. You always want to do that. Now we put this in trigonometric form, and we go ahead and do this. And if you notice, they're the same, right? So what that means is that, right, if I looked at this equation here, because these being the same, I can see that cosine of 32 equals the sine of 58. And this is an important concept. If the cosine of A and equals the sine of B, that means that these are complementary. And you could do the converse of that as well. Okay, so let's try another problem. Okay, so go ahead and make this diagram, and we're looking for x. Okay, all right. So I'm going to speed this up a little bit to get us where we need to go. Okay, so here's our angle. This is our angle of interest, and right now, like before, we have the adjacent to this. Okay, so again, we're going to probably use one of these. But now I have this side. This side represents the opposite side. So in this case, I'm now going to just use my tangent. So I have that. I'm going to go ahead and write out my ratio. Tangent is opposite over adjacent. I'm going to do my setup. And now I'm going to solve. Now solving this is just a proportion, which we can use cross products. And go ahead and solve for x. That's our setup. And we would get this. And this would be in our trigonometric ratio. So if you just wanted in terms of trig values, that would be it. Of course, you can plug that into your calculator. Okay, so our last problem to practice with, it's an application problem, and this comes up very frequently. And this is really the power of trigonometry. It's answering questions what's called indirectly. So pause, take a look, and draw this diagram so we can solve this problem. Okay, so hopefully you're back. A radio tower is 100 feet tall and it's supported by steel cables. So here's our cable over here. Okay, and it's attached to the ground. And according to the building code, this has to be at a 50-degree angle. Okay. So with this all being said, we're asked two things. What's the length of the cable? So we're asked the length of the cable from here to here. Right, this length, and how far from the base of the tower should the cable be attached. So we're asked for this distance here. Okay, so we'll just say see cable length in this distance. So these sort of problems are very common, and you'll see these, and they have to do with right triangles. And maybe at first you don't see the right triangle, but there it is. Okay, we always assume like a tower or a building or something makes a right angle with the surface of the ground. So again, this is just a right triangle type of problem that we would use trig. Here's our angle that we care about. This would be considered our opposite side, and the cable here would be our hypotenuse, and this adjacent side here would be the distance away from the tower that we would make our attachment. So we're going to go ahead and